This is 2017 European Girls Math Olympiad problem number 1, and here is a view of this geometry problem. ABCD is a convex quadrilateral with angle A and C both 90 degrees. That suggests that our quadrilateral is indeed a cyclic quadrilateral. So I will first draw the circle, I guess. There you go. And then based on that, we can do some action. Oops, not a circle. Yeah, this one looks more of a circle. All right, so let's draw our cyclic quadrilateral, something like that, I guess. I don't know. We have our cyclic quadrilateral A. This is a 90-degree angle. B, C, D. That's a 90-degree angle. ABC is greater than CDA. Oh gosh. That's not gonna hold, so let's switch those two. Okay, AB, CD, there you go. Q and R are the points on segments BC and CD. Okay, BC and CD, we have Q and R. All right, I'm sure I will mess up again, but okay, so let's just pretend this is Q, that's R. Oops, R. Intersects AB and AD, so AB extended, QR, something like that, intersects right here at the point AB extended at P, and AD extended, this one, at S, that's S. These points are collinear, believe it or not. Okay, I messed up my picture pretty badly. Okay, come on. All right, this is the point D here. All right. What else? It's given that PQ is equal to RS. Okay, so maybe I can have another color. So this segment PQ is apparently equal to RS. It doesn't seem like that, right? So I can maybe do a little bit things here, just slight modification to my picture, so to make it look like they are more equal than okay, so there you go. So this is the point R, and the other green segment would be this one over here. So these two green segments, they are congruent, RS here. This was a cyclic quad. All right. Let the midpoint of BD, okay. BD, the midpoint, well, it's a special point, right? This is actually the center of that circle as well, ABCD, right? What else? So this point is M, which is, like I said, the center of our circle, and N is the midpoint of QR, okay. Oops. Sorry for that. The midpoint here, and then the claim is that actually, let me just move M a little bit down so it's, yeah, so somewhere here. All right, the claim is that M and AC are on a circle, so the 4 points A, M, and C, so we need to show that those 4 points are concyclic. Well, assuming that you guys have already spent time, or if you want, just pause the video, right? So spend time on this problem. The critical move, or the observation I should say, is that N is such that, well, because Qn is equal to NR, it's given in the problem, then, and, well, because PQ is also equal to RS, N happens to be also the midpoint of PS as well, so Pn is equal to NS as well. So that's kind of the critical move of the problem. Once you notice this observation, which is, like I said, yeah, the crux move, yeah, so then you can draw AN, and because PAS is a right triangle, PAS is a right triangle, then PNA, A, or less, well, this is a right triangle, implies that, well, because N is the midpoint, the AN is the median, implies AN is median, and PN is equal to NA, PN is equal to AN, which is equal to Sn. This is a property of a right triangle, right? So the median An has this very nice property. But then that implies that PNA is an isosceles triangle, as is SNA. They are both isosceles. So let's, I don't know, we can mark these angles. So these two angles are equal, and those two angles, so I can put double, those two angles are also congruent. Now to finish the problem, I will just compute ANC, angle ANC. Let's check angle ANC, which is just a combination of A and P, angle ANP plus angle CNP, CNP. Well, for angle ANP and CNP, all right, for angle ANP, right, so angle ANP is just the sum of, let's call these two as alpha, and this one as beta. This one is beta. Do you guys agree that ANP is just 2 beta? Right, so this is 2 beta plus CNP. CNP, okay, let's just have this here, is this angle over here, which is just the sum of these two tiny angles here and here. But wait, well, yeah, we can call them as theta each. Why? Because CQR itself is a right triangle, and CN is a median in that small right triangle. And yeah, so they are both theta, which means this one is a theta. Yeah, let's just leave it like that. So it's just plus 2 theta. That's it. So A and C is just 2 beta plus 2 theta. But this angle over here is an exterior angle of triangle RDS, and as such, this is theta plus beta. Aha! So we are done, right? So which is equal to 2 times beta plus theta, but beta plus theta is just 2 times angle CDA, right? 2 times angle CDA. But notice that 2 times angle CDA, because CDA is an angle on the circle, it should be 2 times an angle on the circle should be the central angle, which is CMA, right? So angle, or AMC if you will, AMC. Wow, angle ANC is equal to angle AMC, and we are done. So that establishes that this quadrilateral MNAC is just cyclic, and that solves the problem.